Good day, guys. Once again, welcome to our YouTube channel. Uh, yeah, we are excited to welcome you guys, and we will be continuing with grade 10 physical science. If you haven't watched the part one, I think you can go and watch part one so that you can, understand. And it's going to be a short one. So, okay, yeah, guys, let's continue, guys. Okay, on the previous video, we spoke about metals and how to break your metal down. You have to check whether it's solid, uh, it's liquid, or it's gas, and then from there you check, do you have a mixture, or do you have a pure substance, and then you break down now your mixture, and then you break also your pure substance. This is what I'm talking about. And like I said, guys, I was explaining this on part one. So if you wish to understand, go back to part one. Okay. So yeah, let's continue, guys. So now we're going to break down this part because I know. Okay, we're going to break down this part, mixture. Okay. Now, in mixture, guys, you need to understand mixtures consist of different substances. We all know that. Think of a Coke, think of an orange juice, think of pure water, think of a tea. All these mixtures, they consist of different substances. Okay. The substance that you find in tea, sometimes there are certain substances you cannot find in orange juice, in a Coke, and whatsoever. But then we know at the end of the day, water has to be there. But then there are certain mixtures, there are certain, not mixtures, there are certain elements or substances that you cannot find, right? So let's continue. So now they say a mixture consists of different substances, and it can be a homogeneous, right? Or heterogeneous, right? I will explain the brackets part after explaining what is a homogeneous, what is a heterogeneous. I Trust me, guys, from today you're gonna be able to know. I believe you're going to go with this understanding between homogeneous and heterogeneous. The difference is very clear, and you are going to be able to determine whether a substance, a mixture, is homogeneous or heterogeneous. Now, let me make an example, a quick example for you guys. So now, you're going to have, let's say we have two identical jars. Ne? You know those lab jars? Yes. And then, okay, now they're identical. Let's say they're identical. I'm going to use blue for all of them. Okay, good, perfect. Now, in these jars, guys, ne? And then we can fill our jars. Okay, let me do this. We can fill our jars with liquid, mainly water, so that we can see what's happening inside. So inside here, okay, now I decide to do this. Okay, let me quickly do this for you. I decide to do this, guys, ne? For this one, I decide to add salt, right? Yes, I decide to add salt. And then, okay, let me do this. And then on this one, I decide to add, what can I add? Soil. A soil, yes, a soil. A soil, right? Fine. Now, in these two substances, maybe, okay, this is my tiny, okay, salt, right? The salt is going to be like this, and then I know, or soil, I know, my, obviously the color will change here inside the water. Now look where this thing is going, guys. Okay, fine. We have two jars. One we poured salt, the other one we poured salt. Now in salt, if you can, let's say we give it a 5 minutes or so, and then we come back again. Now we are here. We come back again, Okay, we are here. We come back again to check our substance, and then we find that the salt has dissolved, right? So now if I come to you with that same glass and then I tell you without tasting, without doing anything, and be like, do you think this water is pure? Obviously the answer you might say yes, because the reason why, you won't be able to see the salt inside. So that substance, that pure substance, that mixture, I mean, not pure substance, not pure substance, that mixture, it's called a homogeneous mixture. So a homogeneous mixture, um, homogeneous mixture, let me fill it here, so that a homogeneous mixture have the same look, meaning you can't distinguish, you can't tell whether there's sugar inside. Same, I can make an example with vinegar, I can make example with what, any substance that you're going to pour inside the water, you won't see the difference, I won't be able to tell. So that substance, we call it a homogeneous. Now a heterogeneous, if I come to you with a glass filled with soil, I mean, you're going to tell, you're going to be like, nah, there's soil inside the water, because why, you can see, you can see this, you can see the different substance, understand? So now you can say, you can see the different substance. Okay. Oh, perfect. Now this is how we distinguish between a homogeneous. So now let me do this. Now homogeneous, it will be this one. Yeah, this is your homogeneous, because since we cannot distinguish the difference, so you cannot come and tell me what, now you notice the salt digamo. I mean, unless you have those super magical powers that are what I don't want to mention, but then yeah. So guys, this is it. So that's how we differentiate between a homogeneous and a heterogeneous. So every time when they ask of homogeneous, think of a salt and water, and then heterogeneous, think of a water and soil. So yeah, let's continue, guys. Okay, we're gonna go to number 4. So they say some of the properties of the metal. Okay, they say some of the properties of the metals. Or excuse me with that, guys. Let me use this red one here. They say some of the properties of the metals, that they can conduct electricity. Yes, we know. We have metals that this is what I was talking about here. And again, guys, if you didn't watch part 1, please go to part 1. This is what I was talking about, ductile. Ductile are metals that when we cast them into various shapes, we can form those electrical wires and whatsoever. So now again, some of the properties of the metals that they conduct electricity, heat, and they are what? They are malleable and ductile. Right? Malleable, we know again, it can be hemmed and pressured, but then it doesn't break. Same as a wire. Wire, you can put pressure on, and then obviously, and then also we can cast what, a metal that can conduct electricity. Okay, continue. Okay, number 5, a non-metal are non-conductors of electricity and heat. Think of a what? A broom. Lifielo la gota, angere. And then if we know lifielo la gota, a wood cannot conduct electricity. Okay, there are gases, a gas cannot conduct liquids. But then here I'm skeptical, because but as time goes by, you will get to learn and see that basically water is a good conductor of heat, because if I can put a wire, a strong voltage wire inside the water, and I ask you to touch that water, believe in me, you're going to get shocked and whatsoever. So which means it's a conductor of electricity, which means the electricity can move from the wire to the water and to you. But then for now, take it as like the gas, liquid, or brittle. Okay, solids and bond. Okay, there are many examples. So just when I know these ones, gas, liquids, or brittle, right? And then We have also types of metals, and this is the type that I'm making example with. Metalloids are elements on the border between the metals and non-metals, right? And they have both metal and non-metal properties. So, but then the most I would want you to know is that the non-metals, the, the, the examples of non-metals are this one. There's one that you can grab, and then non-metals. Oh, non-metals, yes, are this one, and also think of wood and whatsoever. And then also we have some properties matter that conduct heat, and they are what? They are malleable and ductile. So, guys, I think this is the part where we're going to end, guys. I was explaining, okay, continuing where we left off, and I'll see you guys on the next episode. Ciao, ciao. Thank you, guys. Oh, okay, so wait. Please, 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 please like, share, and subscribe. Thank you, guys.